megawatt scale charging system for EV trucks and buses, boats, planes, and mining machinery. It's like long queue of appliances. So to start with, I'll invite Mr. A.K. Jain, who is going to chair this session. He is chair of ETD 51, Bureau of Indian Standards. Welcome, sir.
Good afternoon.
I would invite Mr. Gerald Grampel, Director Corporate Strategy, Verbund AG Australia. He'll be on video. Now I'll invite Max Chioldi, Vice President and Market Manager, HPC. Thank you. Max, welcome. Another panelist is Dr. Rajendra Singh. He'll be joining online, and he is from Clemson University. Our next panelist is Giridharan P. He is Application Manager, Hitachi Energy. He also will be joining online. And Jaiprakash Singh, may I invite Mr. Jaiprakash Singh? Jaiprakash is Business Head E-Mobility Adore Degatron. Welcome, Jaiprakash. And our next panelist is Mr. Manoj Gupta. He is Executive VP, JBM. Thank you, Manoj. So now I would request our chair to start the session with his opening remarks, and then we'll take it over.
So good afternoon to all. I am audible? Okay. So distinguished panelists on the dais, and my EV lovers and respected people sitting here in the session. I think it's after lunch, so maybe some time people will take to join, or Anand, I think, is it?
So every time after lunch is a little difficult to make you running and reach.
But anyway, I think people may join slowly, as Anand was telling. So a very good afternoon to you all. I think first let me thank ISGF for inviting me and chairing this very important session on megawatt scale charging. And very eminent people, very masters of the field, people are on this panel. So I am sure the discussions and the deliberations, what will happen today, will definitely, make a thought process for further, actions to achieve our ultimate goal. And I also, compliment ISGF for organizing this mega conference on very important topic of smart energy and smart transportation. And net zero transportation is the call of the day. We all are, aware how important this topic is. Already our Honorable Prime Minister has given a call of in the COP26 for India net zero emission at 2070 and reducing the CO2 emission by 1 billion ton by 2030 from that time. So these such things are already, he has given a 5 nectar, that is a Panchamrit. So how this is possible now? We all, industry partners, the auto leaders, the utility people, the infrastructure provider people, they all have to work together. And I think this is, we are going to achieve this target the way government is acting on all fronts, intervening, providing support, providing incentives, whether it is through the FAME scheme or the PLI or National Mobility Mission. Many things have happened, and industry has taken this challenge. And many challenges industry has come across during last so many years, and every time they are the winners. And this particular subject is a game changer for the whole auto industry, and I am sure the type of panel we have will enlighten more on this subject by these experts. Only thing I want to say is that we started our journey with a small way back with small chargers, 10 kilowatt, 20 kilowatt, 25, 50, 120. Just now we was talking about 360, but now today we are talking about 10 times of that. Let us say 3.75 megawatt or more. I just learned that Hitachi is also developing 8 megawatt charger. And just now he has shown me the gun which he will show you. So the way, things are progressing, technology is advancing, people are coming forward. This dream of net zero emission will be realized, and the way people are adopting the EV. If you see the, exponential growth in two-wheeler, three-wheeler, and now four-wheeler passenger cars are catching up. So, and the charging infrastructure, what now people are putting up, it has given a lot of comfort to the user. Their anxiety about where I will get my charging done, where I will get my battery, whether I can go 200 kilometers in a stretch, 300 kilometers, that all is now getting, over. And when we talk about this today's topic of megawatt scale charge, this will be a major, help in overcoming the CO2 emissions from the heavy trucks, buses, intercity. Because India, most of the freight, more than 70% is through the road and trucks only. And out of that, maximum is through the heavy trucks. So the way things are happening, the way India is experiencing this historical growth, this industry will rise further. And what I have read is by 2050, there will be four-fold increase in the number of vehicle trucks and heavy trucks in India. So it gives enough space for all the operators to get their pie. Now the call is how all auto leaders, industry leaders, technocrats, innovators, government policies, framework, they all come together and work in a collaborative, cooperative and understanding manner to provide a very safe, reliable, robust, accessible and affordable system for heavy segment of traffic. And that is possible if all industry people bring in their experience, expertise, innovations and work in a common goal to ease the comfort for heavy truck movement and also to help our Mother Earth become a livable planet henceforth. So I am thinking that this high megawatt, 3.75 megawatt is a big, there's a high kiloampere currents, kilovolts ratings. So it will give a lot of challenges because I am doing a lot of work for small chargers, 20 kilowatt, 50 kilowatt. Still that we are facing a lot of problem in getting the, upstream network. Isolation transformers, feeders, all things we have to design, put in the place along the highways where not much facilities are there. So designing this system is one thing which is happening. Secondly, implementing this system across the highways, on the roads is another challenge. Then integrating with the utilities, how they cope up with this load, our power utilities. Those things have to be put in a holistic manner by all people and then taken a call that how we provide this infrastructure in our country. And world over, developments are happening. There are companies who are collaborating with technology partners and providing this solution. So I am sure the deliberations and discussions today will definitely give us the insight into the design aspect, how a single conductive conductor can take this much of load, what type of cooling, what type of such a high current and voltage handling, what type of safety to be adopted, what type of EMI, EMC shielding to be done, what type of, things to be put in place so that people are very safe, they are comfortable in handling such high voltage and current. So all those things, I think, as the designers are working on it, and I am sure that with this type of, transformation happening in technology, innovations happening in technology, we will definitely reach our goal of providing this to the Indian roads, and people will have this, maybe down the line, that India is now, will lead from front in EV charging space, in EV vehicle space, whether it's Indian market or export, I think. And with this, I will give it to Anand, and thank you very much for giving a patient hearing. Thank you.
Thank you very much, sir. Thank you very much for your opening remark. So now I would invite our panelist from Austria, Mr. Gerhard Gamperel, Director Corporate Strategy, Verbund AG.
I'm happy to start. Thank you very much for the invitation to be part of this big conference. I'm very sad that I cannot participate personally because I have been to ISUW 2 times before, and I really appreciated the conference and being together with Reggie and all the very interesting speakers from many countries all over the world. So I just start with my presentation. I was invited to have a short presentation on electric mobility in Central Europe and to present some strategic cornerstones. And what I want to start with is in Europe at the whole value chain of electric mobility, whether this is a private automobiles or whether this is lorries and trucks. So what you see here, this is 7 important parts and puzzle stones from the value chains. We're starting with hardware and installation, whether this is AC or DC, this is all the technology, this is project planning, consulting, and all the hardware retail. In one of my next slides, I also put figures behind those 7 parts of the value chain. So the second is asset ownership. Someone is owning those assets, charging assets, and there's a very strong trend to commercialization of charging services, etc. And there's a lot of different, a whole variety of different operators, but I can say that the majority is the big utilities all over Europe that are in the asset ownership. Next is the operation, we call it CPO, the charging point management. This is including all the operational businesses, including field service maintenance and customer contact care, customer contact centers. Next is the software issue. It's the platforms that are behind operations. It's the combining of the charging stations with data management and the integration into the mobility services. And mobility services is fifth. This is, we call it MSP. This is the direct contact line to the customers, whether this is billing or payment. This is the access and the integration, roaming. When you're moving from one to the other countries, of course, you want adequate roaming services and being charged very easily and comfortable. Then, next, energy management. I'm representing Verbund, which is the biggest Austrian utility. Energy management, the combination between electromobility and the energy supply. This is a very complex thing and very demanding for us. And there's, of course, there's a lot of value pool behind, because we furnish the necessary energy for all the charging stations. And there is just like load shifting, peak saving, demand response, etc. And the last thing is, of course, you need the electricity grid. This is the right thing for this conference, here for ISGF conference, because we need all the networks being in the position to fulfill the demand for charging. Next is, I've put numbers behind that, and just to give you on the bottom line the relevant figures. If you look to Europe and you have the revenue pool 2022, it's around about 7 billion. All these 7 different parts of the value chain, 7 billion euro. And if you go into the extrapolation into 2030, which is only some 8 years ahead of us, then you're more than 30 billion. So you see a dramatic increase. You multiply it by 4 in the next 8 years. So this is one of the big new market fields that we see in Europe when we go into CO2 neutral or CO2 free transportation. Next is because this topic is also heavy machinery, whether this is ships or trucks, etc., etc. This gives you a short look into 2030 expectations when we look into the truck fleet versus the passenger fleet. In the middle, you have this chart where you see that end of 2030, that is really interesting and astonishing also for us. There's a dramatic increase in the EV, in the electric truck fleet increase, and we expect that rather more than 30% of the demand, electric demand in 2030 in Europe will be driven from trucks and from lorries. And if you look into the CAGR on the left-hand side, the increase rates between 2022 and 2030 is plus 67%. So this is a dramatic increase versus on the right-hand side where you have plus 26% only per year when it goes into the passenger fleet. So what we see here is that there's going to be a very dramatic growth of electric trucks in Europe, and we see it from the big manufacturers, whether this is Mercedes-Benz or Volvo, Scania, you name it, that they have increased rapidly also the different types of electric lorries that are going to be put and implemented into the market within the next couple of years. So a deeper look into the charging structuring when we talk about electric trucks. What you see here also in the middle column is our expectation by 2030 is that we have 4 different use cases for charging lorries and trucks. This is public fast charging, destination charging, public overnight and depot. And what you see here, that the top and the bottom use case, this is public fast charging in the public areas and depot, where the lorries and trucks are kind of at home. This is more than 60% of the demand will be charged by lorries in these 2 use cases. And what we see here also when we talk about public fast charging, this is only half an hour up to 1 hour. So there's a really huge demand. This is DC 500 kV or more. So this is going to be a very challenging situation for all the networks and for the grids that we have in Europe. Next slide. This is the expected ramp up for Germany. Germany is the #1 market, whether this is the different industrial markets, but also of course in the EV fleet. And what you see here between 2021 and 2030, that we over 10 times more cars, electric cars, and BEV means battery electric vehicles, and PHEV means plug-in hybrid. You see in 2021 it was almost half between battery and plug-in hybrid private vehicles. When you look into 2030, you have almost 80% of the cars in the market in the market will be battery. So plug-in hybrid is kind only of a bridging technology, and what we see is that it's a clear focus into pure battery electric vehicles. One glimpse also for Austria. Austria is in the heart of Europe and 8 million inhabitants. And what you see here is that we have already 15,000 public available charging points in Austria, and also big increasing rates. There's also a law being prepared all over Europe in the EU that by 2035 it will not be allowed to sell any combustion car, and that it will only be allowed to sell by 2035 only battery cars. So this means that the people are looking into 2035, 2030, 2035 and say, okay, there's a huge shift into electric vehicles, also from the regulation side, also from the EU side, also from the Brussels side. My last slide, I'm coming to the end now, just giving you a glimpse. I have put here in the chart that you see it started with little companies being in this market. It started with subsidiaries from the utilities, as I said before, from all the relevant utilities, whether this is EDF, E.ON, and whatsoever. And if you go up here until 2022, you see the big names. Here are the big investors, whether this is EQT or whether this is BlackRock or Shell or others, meaning that the big capital has also discovered that this is going to be a very relevant market, and that's why they are buying those smaller companies, and they're integrating it, and they're forming bigger corporations in this field. So there's a huge transition in the European market. And yeah, this was my presentation. Thank you again for the invitation. Happy if we have some time for a Q&A session in the end. Thank you. That's it. Bye.
Thank you, Gerald, and thanks for discussing about all those strategic opportunities that is lying there. And we had a previous session about electric highways, where most of the time we talked about the challenges. So now in this session, we are going to talk about the opportunities those challenges are bringing in. And we have people, I'm sure that they have the solution to offer and to deal with the opportunities that has come in front. So I would now invite Mr. Giridharan, who is application manager Hitachi Energy. Giridharan, if you can hear me.
Yeah, quite audible.
Yeah. So
I'm just sharing my screen.
Yeah, over to you. Please go ahead.
I hope my screen is visible.
You can see your screen. Yes. We lost it.
Okay. So
yes, it's there. It's there. You can go ahead.
Yeah. So the key topics that I would like to cover is like, as such, Mr. Geras has indicated. So it's, I mean, the EV from all the spectrum, it is going to impact, will have an impact on entire stakeholders. So I will also touch about the different stakeholders and their role in this overall this e-mobility nexus actually, and also what will be the different charging strategy that we will have to have, because one size may not fit for all the vehicles and for all the consumers, and what sort of infrastructures that can be sustainable for a overall development of this EV platform, plus also how this the digital technologies is going to help the utilities, and then also the users in this ecosystem is what the topics that I'm going to discuss now. So the very first topic that I would like to touch about is like, so basically e-mobility, it requires an involvement from various stakeholders, like typically a bus OEM has to be onboarded, and then also the transport authorities, plus the type of charging infrastructures, plus the different type of a battery chemistry that you are using here. So all these are a matter of concern because the industry cannot function I mean, it by its own. So everybody has to collaborate each other to resolve the challenges posed by this requirement of EV charging infrastructure as is required. So I'll just go through the different charging strategy that has been anticipated. As I mentioned, one size may not fit for the entire spectrum. So when it comes to the charging strategies, overnight charging can be an ideal fit if you are talking about for a small operations, or let's say if it is for a personal vehicles which is covering a range of 200 to 300 kilometers of overnight charging, or maybe like even if it is for a last mile delivery vehicle, a overnight charging strategy could be an ideal fit. So basically your charging infrastructure has to be concentrated on one location. So in the case of a bus, if it has to be planned for an entire day operations, the entire charging infrastructure has to be at concentrated at depot. And then just in case if it is going to be an um, I mean, but the thing is like the infrastructure's cost and then also the amount of power requirement all has to be concentrated in the in depots actually. But if you likely change the strategy, like for example to carry a passenger vehicles and then to keep these vehicles and the number of vehicles optimized, and then also the to reduce the charging infrastructures, you can also have an terminal charges at the bus terminals actually. So instead of having all the infrastructures populated in one place, you can distribute the charging infrastructures across the places so as it can bring down the impact on the distribution grid actually. So that is one way. And other way is like you can distribute the charges further even at selected stops actually, in case of an if it is going to be a dedicated road, and if you have some dedicated stops where you have an supply availability, you can have this flash charges actually. But all this comes with a different I mean it has to come with the support from different stakeholders, especially when you are going for a high power charging. So I'm talking about at least in the megawatt charging application. So basically, megawatt charging application has to be supported by the battery OEMs. So the regular batteries with the 1C or a 2C cannot able to take the take the charge from this high power chargers. So basically, the battery chemistry has also to be revisited in this application. So that's what I'm saying. When we talk about different charging strategies, it is all about um, having a different involving a different stakeholders, and then having a different technologies in place so as it can have a lesser impact for the utilities to facilitate the requirement, and then also reduce the I mean to have an optimal resources in terms of number of vehicles, and then also reducing the number of chargers, plus also to avoid the congestion at one place. Just wait. I mean, the vehicles that are waiting to, I mean, that are queuing up to charge actually. So that is from the charging strategy point of view. And then other part is like it's also like the fleet approach. So instead of having the individual distributed chargers, you can also have a fleet approach. So where thereby you can have a single unlike the conventional method, you can have a bulk rectification and then distribute the charges bulk rectification and then distribute through different DC power converters, and then efficiently handle it based on the charging needs actually, or based on the consumer that I mean that are I mean that are concentrated in that particular locations. So basically demand aggregation is also to be one of the key point there. And other thing is, as I mentioned, to reduce the impact on the grid, we can have the chargers that can handle directly on the DCs actually. So you can have a common infrastructures, like as I mentioned, you can have one complete rectifications or bulk rectification, and then you have a DC-DC converters, and you will have a different interface to serve to cater to the different vehicles actually. So for a kind of cars, bus, and then also the high power chargers, or even it could be in the trucks, those can be served on a common infrastructures just by changing the interface of the the connectors actually by having a common power infrastructures. So as I mentioned, we have, I mean, like it is basically to have common power infrastructures and then have a different interface to cater to the different vehicles. So as the infrastructure vehicles depending on the consumers you would like to serve. So that is one way of reducing the uh, um, uh, uh, the various infrastructures are also like you that will help to have a demand aggregation in place. So uh, it's like having you can of the petrol stations that you hit on the road. And as I mentioned, and vehicles comes with a lot of technologies as well. So basically, you will parallel typically serve for a charging requirement of forward with the same charging infrastructure. So this is one part. And the last, so typically by having this, bringing the many parts of the e-mobility into a common digital platform that is starting from telematics to energy management, you can introduce a coordinated charging. So basically you can optimize the amount of power that is required to charge all your vehicles by having this digital platform. So basically, you need to coordinate with the, in case of fleet operators, just for an example, e-buses actually. If it just in case they wanted to follow the timetable, so you can prioritize your charging based on the bus operational timings, plus also the number of buses that are en route to the charging stations based on the GPS coordinates, and you can prioritize which bus to get charged first and then which one to go last. And then some buses arrival of some buses to the depot may be delayed because of the prevailing traffic conditions. All this can be coordinated with the fleet telematics, and then also the availability of a chargers in place, because some chargers, the availability of a chargers is also a matter of concern. There is a cooling time between one charging to the subsequent charging. So all this can be coordinated, and then you can really optimize the power need, and then that will have a lesser impact on the grid. So just to give you an instance, an uncoordinated charging of some 100 vehicles at a single vantage point will require a peak power of around 4 megawatt actually. So, but when you try to optimize it with the coordinated charging with the digital solutions in place, the same number of vehicles can be charged with a peak power of 2.2 megawatt actually. So that all comes with the prioritizations, and then also the bus route optimizations, plus it also follows the timetable and then the needs and priorities, plus also the traffic conditions prevailing in the surrounding areas. All the situational awareness can be brought into place, and then you can do a charging. So but this already this megawatt scale charging can be already we are realizing it, and then also even for the mining applications, I said, I think just before the start, just before the event, we have been discussing this. So even this we are already realizing it with the help of a different battery chemistries. So 8 megawatt of a charging is already a work in progress, where we are using the different the PAN2 interface to have a common infrastructures, and it is with the different battery chemistries of LTO, we are realizing the high power charge rate of 9C, and then catering to the mining applications. So that's where I will stop, and I'll hand it over to for the subsequent discussions.
Thank you, Mr.
Thank you.
Giridharan. Thank you for this excellent presentation, especially the last slide where we saw that 4.8 megawatt of peak load, and then with the very simple arrangements, this can be bring it down to 2.2. So that is one thing that needs to be understood when we go towards the heavy charging or larger megawatt scale charging, that how this is going to affect the grid. We are doing a study at ISGF for Calcutta, where West Bengal Transport Corporation is planning to have 1,200 electric buses. They will be having it on the grid, and now we are trying to understand that once we have so much of charging happening inside the grid, how the grid is going to behave. I mean, now they, as a bus transport operator or state transport unit, they do not know or they not much understand about the electricity. But now they would have to understand it with the help of the vendor or OEM whosoever is coming on board and making it the solution. Though this is in GCC model, but it's their own child and they have to grow it up for next 10 years and then understand that how things should be operated. Or such kind of studies are going to help them that how grid would behave, and as soon as we are getting the number of buses coming into the grid, 300 maybe in 2 years of time or 3 years of time, 300, next 400 and next 500 or next 600. So how going ahead the grid would behave in next 3 years, next 7 years, next 10 years. So we are trying to understand how it would be. Anyway, thank you very much for this session. Now I would invite Mr. Max Gioldi, who is Vice President, Market Manager, HPC, Habershiner. So please come to the stage. Thank you.
So I'm a very simple, easy man. I listened today to all that speeches. It's a very big, complicated world we are going into. I'm a handyman. I brought a sample, so I'm not going to bother you, obviously not even with my presentation, so I'm not bothering you with big figures. I am working at Huber & Suhner. We are a Swiss company working in different markets. We're making cable for railway, telecommunication, and so on. About 7-8 years ago, German car manufacturers approached us and said, how can we have a car charged in the same way we're charging, or we are loading the gasoline today? So our engineers started working. We have to be the first one, and I brought you the sample. That's a 500 amp cable. That means this solution is applied in high power charging. And I'm sorry if I'm listening, I'm always a bit smiling if I'm hearing fast, quick, or whatever charging, and then we're talking about 50 or 100 kilowatt. In our words, fast charging is 350 kilowatt and above. So our focus, and I think there's space for all the different charging. So I'm not going to talk about home charging. I'm not going to talk about mainly depot charging, or work charging at work. I think high power charging, as we call it, is designated for highway, for cities, for people who have no chance to charge at home, and I think that's the big change. You know, in Europe, we just finished the first mover time. That means in the beginning, guys driving an electrical car, they're willing to do some efforts to get their car charged. Mostly it's people with own homes, means people have money. But now the change is it's becoming commodity. There are a lot of cars coming, and there's simply not enough homes charging, factory charging, and so on. So we need high power charging in the cities and the highway and all where there's a lot of traffic. And there's not only one reason. Even if you could charge with 50 kilowatts, if you consider how long it takes and how many cars there will be in a few years waiting to be charged, so simply on the number of charging stations, and I think in Europe it's not so much just the number of charging stations, it's even more the place, the parking areas, and the willingness of people to wait. So to reduce that time, to make it attractive for the charging companies or the utilities selling the power, they want to charge as quick as possible because a car standing in their parking lot charging for 2 hours. It's not really bringing money, so you want to have that car gone away in 10 minutes and having the next one. And that brings us to the next one. That's the difference between peak charging and cooled cable solution. So we are making cooled cable solution. So if you're talking 500 kilowatts or even above on that solution, we're always talking continuous charging. At the moment, in the beginning, yes, you can use dry cable. You can make peak charging. Peak charging means you can charge for a few minutes higher current. The problem is the whole system is heating up, and then it takes a long time to cool down again. That means if you're the first one, you're the lucky one. You may get quick charging for the first 5 minutes. But if you're the second in a row, there's nothing left for you because the whole system is overheated and needs to cool down. So that's just a few things. So the learning is, and I think that I did hear that many times, it's the chicken and the egg questions. At the beginning, there were no cars, so nobody wanted to invest. Then we got some incentives, some programs like Electrify America was lucky enough to get sponsored by some German companies to set the basic network in place. And I think that's the challenge you go through in India, because in the beginning you don't make money setting up charging stations. It costs a lot, there is a lot of investment, but it's very important to have the right investments. So at the moment, you know, in the beginning everybody was screaming about chargers, and then they realized, oh, there are no cars, and now the cars coming, the chargers and the technology is there, but now they struggle on getting the spaces, getting the grid connection, getting all the approvals, and I think that's one of the big challenges between many others, bringing the power to the right point. And I mean, we're talking about 10, 20, 50, 100 charging stations on 350 kilowatt, and you can imagine what kind of power you need there. And I think the load, yes, in the beginning, that's always a challenge. The peak load, I think in Europe and some places, if the grid is not that great, they're using battery backup so they can cut the peaks. But in mid-term, if there's one car after the other, that doesn't really help. That means in future, one day you will get away from peak charging, then it's continuous high-level charging. So just for the ones who are not or never saw it, that's the standard, that it's not only Obersunder, there are many of them, standard interface CCS2 for up to 500 kilowatt according to the standard. We can charge 800 amps. Depending on the voltage of the car, you can calculate how much that is. But we were talking not only on the cars, you were talking about trucks. And trucks is a very different story. On the car, that initial push that came through the politics, that means the governments and other organizations were pushing and trying to find a way to make it attractive. At Charin, we started talking a couple of years ago about standardizing the next level. That means megawatt charging. What you see, that's the standard interface for megawatt charging up to 3,000 amps. And you see, I'm always talking about amps because as a cable manufacturer, the voltage is not a challenge for us. The amps is the challenge. So again, here we have the same thing. We cool the cable by a liquid. So we're taking away some of the heat. This is the size of a 1,500 amps, just came out of the lab. Internally, we made all the tests. It's functional, it looks good. It's now at the first customers' places. Oh, yeah, it came, great. it's at the first customer places for testing to trucks and other vehicles. Here you just have a picture how we cool it. We bring in the blue arrow, shows the liquid, the cold liquid going through the cable, cooling around the pins on the way back. We're cooling directly on the copper in between the power lines and the insulation. So it would be in here and here. So it's directly on the copper. It's an insulated coolant, so there's no risk, even if something goes wrong. Going back to this one, 1,500 amps. That's the first. By the way, that's the dual charging. You can use two guns, as you call it, at the same time. It was the right picture before, with the two cables. Here, go to the next one. Down, yes. Stop, one back. Okay, this one just shows you on the, which side is from you? On the left side, the bigger graph. I can see it, I just didn't know how they look at it. Yes, so you're right, it's the same. On the left side, you see the impact on cable length. So as shorter the cable, as higher performance. If you see the top line, that's somewhere about 900 amps charging. Again, that's this one, but of course, it's an industrial product, so you should not go to the max. Next slide. Here, this was talking about maintenance. It's maintenance-free solution. Critical part is always the front. If they drop it down or cannot pull it out, it breaks. This can be replaced in the field. Next slide. Then that's one that's really brand new, very innovative. 1,500 amps, next generation will be 3,000 amp. It's in the very beginning. The nice thing is, I mentioned before that the car was driven by politics, by the governments to fulfill their targets. On the truck side, actually, we got approached by the truck OEMs because they realized, first of all, they can save money on taxes if they use electricity, but also because overall it's becoming cheaper after a certain period of time. So the pressure this time is coming from the industry and not only from the politics. That makes it much easier, makes it much more straightforward because the money is allocated. People want to fulfill this because they have a business plan behind it and see the opportunity of payback. Next slide. Then, I cannot even read it with my glasses. Very simple takeaways out of Europe. It's a lot of money needed. There's the biggest concern I see is the grid, not overall. It's bringing the power to the right place, and this takes really long time, especially in Europe, in the different countries, different rules, different regulations, but I guess interstate in India it can be a challenge as well. It needs a lot of locations. It needs big locations. I did here before on the highway presentation talking about using the CCS2 for cars and trucks. That works only short term because as soon as you have certain volumes, a truck driver cannot wait till one of the few charging stations is ready. A truck looks very different than a car. That means the space he needs is very different. I don't know in India, maybe you have some more space, but I trust on the highway also not. So you need to have designated charging stations. So the target in Europe with that 1,500 or in a second step 3,000 amps, the target is that on the highways and all the truck roads that you have as many charging stations, so the driver is driving 4 hours. They are forced to make a break for 45 minutes, and the target is that during his break time he can charge his car. Okay, I'm afraid I already overdid my time, so I could talk for hours. But
thank you very much, Mr. Max. Thank you for bringing all those two guns. First time in my life, I'm not afraid. Somebody who is carrying two guns, and then still I'm happy about it. Now I would invite the next speaker, Mr. Jay Prakash Singh, who is Business Head E-Mobility, Adore Degatron. Please, you can come.
Hello.
Thank you.
Myself, Jayaprakash Singh. I am from Adore Degatron, Pune. We are the charger manufacturers. We are manufacturing DC fast chargers. So, from the power electronic side, yes, of course, it's possible. So, from power electronic side, it's possible to make the megawatt charging solutions systems. But my question here is whether do we require the megawatt charging system or not? So this requirement generally comes from the vehicle side. So generally, if you talk about the bus and the trucks, they are in India at least they are using currently 250 kilowatt to 300 kilowatt hour battery with the charging capacity of 1C or 2C. So if we talk about the demand, 1C means we can charge 250 kilowatt at the speed of 250 kilowatt hour. So 1C battery can take 250 kilowatt hour energy in 1 hour. At the moment we will talk about the 2C battery capacity. So vehicle will remain same, and the battery capacity is also same, but 2C battery is able to take double of the power, means 500 kilowatt hour they can take, and the charging time will reduce 50%, means they can charge in 30 minutes. So here the demand is increasing with the same capacity of the battery and the vehicle. Now if we talk about the 4C battery, that means the vehicle remains same, battery capacity remains same, still 250 kilowatt, but the charging speed will be required 4 times, means something around 1 megawatt hour charger capacity which can feed this much of energy, 250 kilowatt in 15 minutes. That means heavy vehicle can charge in the 15 minutes with the help of fast charger and the more C rate battery. So here the demand is coming. So it's completely depends upon the vehicle manufacturer, OEMs, whether they need this much of fast charging or not. So if this demand is coming in future for the fast charging, from the power electronic side, power electronics is not having any problem to deliver, whether say 1 megawatt or 2 megawatt or let's say 10 megawatt. Because power electronics is capable to deliver even 100 megawatts also. So now the problem will come, demand is there, power electronics can deliver in megawatt. The problem will come from the cable side. Transmission of the energy from the power converters to vehicle. So as Mr. Max already showing this fast charging cables, so we have the method to transfer energy from charger to vehicle via cables. Cables can be natural cooled or liquid cooling. So what actually the factor to deliver the power via cable is the voltage and current. So in this CCS, in India what we are doing the charging with the CCS standard, CCS1 or CCS2, whatever is the same. But in India we are following CCS2. And CCS is having the range of the low voltage. Low voltage starts in DC. In DC, the low voltage starts from 120 volt and goes up to 1500 volt, means 1500 volt. So these cables, charging cables, are able to deliver up to 1500 volt. And if you take the simple example, a transfer of energy with this type of cables, so normally in air-cooled cables, what we are using, whether it is Huber and Schooner, Phoenix or XYZ cable manufacturers, they are using 70 square mm copper conductor to deliver 250 ampere or 300 ampere current in natural cooled cables. And voltage we can go up to 1500. So if I take the example of 300 ampere current carrying capacity with the normal cable at the voltage of 1500, so we can easily achieve something 450 kilowatt of energy. Means we can transfer easily 400 to 450 kilowatt energy with the natural cooled cable. And the moment we are going beyond that the 300 ampere, we need to cool down the temperature of the conductor. So next technology what we are using liquid, maybe water or maybe some other liquid in terms of oil. So by using that liquid cooling technology, and it depends upon the coolant and how fast we can cool the cable, we can go up to 1000 ampere also with the liquid cooling method. Even if we want to go more beyond 1000 volt, that is also possible. Just need to control the temperature of the cooling. If I take example of 1000 ampere, very simple example, simple calculation. 1000 ampere at the rate of 1500 volt, we can easily achieve 1.5 megawatt with the one cable with the power electronics. And now in earlier demand side, when I was talking 250 kilowatt hour battery with the vehicle, capacity of 4C charging. So vehicle demand was coming around 1000 megawatt, 1 megawatt, it means 1000 kilowatt. And the charging time was expected something around 15 minutes. Now, if we are using with a charger, we have the power electronics of 1 megawatt or let's say 1.5 megawatt, and we have the liquid cooling cable of 1000 ampere, which can deliver 1000 ampere and voltage up to 1500. So, if we connect the vehicle, a vehicle is able to take say 1000 volt and 4C charging. So, easily vehicle can take charge at the rate of 1 megawatt. Means 15 minutes vehicle can charge. So now in India, actually what we need to see, do we need the heavy commercial vehicle or bus need to be charged in 15 minutes at the bus stop, depot side or highway side, or we are okay with the half an hour and the 1 hour charging time? So yes, answer is if we go for the fast charging, 15-minute charging, we'll be able to run bus in more highways, more kilometers. Maybe with the stop of after 200 or after 200 kilometer, we can have a stop of 15 minutes and we can run bus further 200 kilometer easily if we are having the fast charging option. If we are not having that fast charging in terms of megawatt, then we need to keep the more battery in bus, means maybe 500 kilowatt to run the 500 kilometer in single charge. That means we are increasing the cost of the bus and we are increasing the weight of the bus. Size, battery pack itself is having very huge weight, carrying huge weight. So we are increasing the weight, cost and the efficiency, we are decreasing the bus. But instead of that, if we are using same kilowatt battery with the more C charging capability and we are using the fast chargers in terms of megawatt, so we can easily achieve that our mission that we can go up to 500 kilometer with the stoppage of 15 to 20 minutes. One stop, 15 minutes, 20 minutes, and we can run the 400 to 500 kilometers, so heavy commercial vehicle on the buses. So yes, as per my understanding, yes, fast charging in megawatt is required in near future for the long run for the heavy commercial vehicle. Of course, in cars it's not required. Cars is okay with the 100, 120 kilowatt or maybe maximum 200 kilowatt charger. We can charge fast in car. But now the question is, now we are having the requirement of megawatt charging solution, and the demand side bus is sending the demand to the charger. Charger we made with the power electronics and the cable capable to meet out the demand of the vehicle bus. But now charger is again connected with the grid and the distribution system. So if you look back again with the transmission and the distribution side, so transmission is okay, grid is okay in India, distribution is weak. So as per my experience, if you go to any state, if you demand 1 megawatt or 2 megawatt at the highway side for the charging station and 1-2 megawatt sanction load from the local DESCOM companies, is very difficult to get the 1 megawatt or 2 megawatt. First, they'll give on the ST line, not at LT. So maybe on 11 kV or 33 kV. And they, the second problem is they are not having this much of a spare load available, power available, and the distribution system is also weak. So we need to work out on the distribution side also, like government, state governments and the local distribution companies need to look out the future charging requirement in India and need to work out, because the distribution lines need to be correct. And that is very big task, because we are ready with the fast charger, we are ready with the fast charging guns, we are ready with the good vehicles which can demand more energy in terms of kilowatt, good battery packs, everything is ready. Technology wise, we are okay. We can proceed with the megawatt charging system in India. But the problem and the bottleneck is the distribution side. So we need to correct the distribution system also, which can be bottleneck in near future in India. So that's it.
Thank you. Excellent points. Excellent points. Deliberation, Mr. Jayaprakash. Rightly said, we did a pilot in Kolkata 3 years back when in FAME 1 all the buses came in. So they had a battery capacity of 300 kWh on board. And the cost was too high to be affordable. So we did a pilot and come up with a conclusion that if we can reduce the battery size, because 40% of the cost is battery. So if you reduce the battery size by half, 50% or 40%, this will serve the purpose. Now we have then we didn't have the customization in the battery storage size and everything. Now we have a customized solution. 100 kWh, 120 kWh, 200 kWh buses are available running in the market. So that solved the first problem. And for buses, it is very easy. You have to run 40 kilometers, 60 kilometers, 100 kilometers across the city. You can go take a run and charge it for an hour. And then you can move ahead, or maybe overnight charging you can done. So partially the problem was solved. But when we started looking into the highways, the freight corridor, and we started talking about the trucks, now you have a bigger problem to solve, because you cannot run your bus 100 kilometers, run your truck 100 kilometers and then stop for 2-3 hours and then get it charged again 100 kilometers, again 1 hour. Because we assume, from business perspective, we assume as a fleet operator that at least my truck should run 400 kilometers a day. Then that will make a business sense for me. Otherwise, it's very difficult. So now this bottleneck of technology, that how do we go ahead and fix it? Partially the C rating of the batteries have solved it. It's like earlier we started with 0.5 C, cars. Now we have 1C, we can see 1C cars running. And there are application solutions, battery solutions available having 4C rating. So now if you have, and with trucks, you cannot carry much of the battery on board because this is inversely proportional to your capacity to carry load. If you have larger batteries on board, then you cannot carry much of the load with you. So we thought of reducing the battery size, and now we are experimenting with 100 kWh, 150 kWh with 12-ton truck. And this will go, at least this, they are ensuring that this will go 125 kilometer in one go. And if we have 3C or 4C rating, so it's just a tea time, a driver will park it, and then within 15 minutes with 304 kilo-100 capacity of charging, this can be again filled with electrons, and then he is ready to go ahead. So partially this solves the problem, and I foresee that in times to come we'll have improved C rating, and the battery technology is also with the lighter side, the weight of the battery, if that can be reduced, that is going to solve another bigger problem. So I think we are approaching to our last presentation. I would invite Mr. Manoj Gupta, who is Executive Vice President JBM. Kindly have your presentation.
Good afternoon, friends. To start with, I would like to extend my heartiest compliment to ISGF, firstly, in terms of, coming up with such a subject, which is definitely a global subject. Firstly, in terms of, the approach, in terms of practices, and in terms of putting up the stakeholders together. So I must say, in this effort, this particular utility week, they have actually connecting the dots, or I can say they are connecting the world, and charging up everyone in terms of all the stakeholders. With this whole starting, I am Manoj Gupta. I represent JBM Group, and I am heading the e-mobility space. We have heard in this panel, starting with Mr. Jain, in terms of setting the context from the utility, from the practical side of, in terms of execution. Then we have heard about in terms of market projections from the high commercial vehicle for the buses, trucks. Then we have saw in terms of availability of product from the Hitachi in terms of its solution approach. And then we have saw in terms of the component, the gun, which is a very crucial element. And then we have listened from Ardor in terms of the DC fast charging. One important thing, we have seen this whole things, if we, try to understand, this whole stuff in itself is, independent items. And in Hitachi slide, they have put one very important slide, that is the collaboration slide, right? So ultimately, the subject of megawatt charging is very, very sensitive subject and very important subject in terms of who is actually the one who is going to collaborate. Because megawatt is not just in the name of a product, right? What we are talking about is a complete project. What we are talking about is a complete service. I am on your side, right? How I give a best of the experience to my customers. This is what we do at JBM. We are the one who are manufacturer of electric bus. We are the one who are operating the electric bus fleet. We are the one who are deploying the large charging infrastructure as a charge point operator with the brand name EcoFuel. So just to set this whole topic, which is a very, very important topic for all of us to see our future ahead. But we have to take a pause here. Just to first understand, where are we today in Indian context and in the global context? It is very, very crucial to understand the ground realities. Because ultimately, again, I am repeating, it's not just about the product, we have to just buy and position, no. It's about the service integration, it's about the planning, and it's about the overall deliverables. And it is about the sustainability of the overall project as a life. And finally, nothing comes free. What's the cost about it? How the TCO look like when we talk about these kind of things. Technology is good to talk, let me put it this way. But how adaptation happen on ground with practical numbers. What is the business model to drive that numbers? And finally, how that projections, what we are talking today, is really become reality and what all we can do together. So friends, to set this whole agenda more simplistic, because I am again among you. So I request, please run a small video, just see how a typical high voltage, the depot charging, the bus operation actually works in India, and we are setting benchmark for the global market. Please. Thank you. So friends, you have seen how a real operation happened, okay? So what you have just seen, it's our 5-year efforts to reach here, okay? And these 5-year efforts have been put together with a combination of selection of technology. We are very, very, careful. What technology, what standards, what make us work on ground. The business model innovation, and finally the people. So this is what is the story behind this whole thing. Now, I will just set the expectations to the whole audience and the speaker on the panel, what is way ahead. So this is where we have reached. And what I'm going to talk with you is very basic operational fundamentals, which are very, very crucial. And why I'm here to look for some good solutions, so some good takeaways. So next, please. So my index agenda for you guys, I have already shown you how we are operating. What is the current establishment with the available technology, product, and the integration, what all we are able to achieve today. So it means plug-in DC fast charger. We are the largest DC charging network deployer today in the India with 240 kilowatt chargers, and we're moving ahead the value chain with 360 kilowatt ahead. And what is way forward? What is the expectation we are setting for the industry at large? Please, next. Yeah. So this is just a summary of in terms of 1,000 DC charging point we are deploying in next 1 year. We are going to deploy close to 5,000 electric bus order book we have today. And we are the one who are operating 24/7 operations. And that's the commitment. And in terms of our ethos for renewability, we have already set a pilot in Leh, the highest point in India, 3,500 meters above sea level, with the renewable source, with the battery chargers and the vehicles. So this is how we are operating this whole ecosystem. And this is how we see the ground realities, which are very, very crucial in terms of the temperature, in terms of the fleet operation, in terms of utilization, in terms of availability of grid, and then in terms of operation maintenance. Please, next. Yeah. So these are the spectrum of solution which we have implemented. So you talk about 360 kilowatt charger with 500 air-cooled gun, right? This is what we have already taken up. Then dual gun charging. First in India, to demonstrate, we talk about the battery 1C, 2C, 3C, and the optimization. So we know time is an essence, each second count for me, whether in terms of money or in terms of penalties or in terms of my operational excellence. So how I bring that efficiency in terms of charging fast. So the dual charging operation simultaneously. Then of course single gun charging, then e-bus depot I have shown you. Then next to the bus, we are talking about trucks. Immediate customer base is the cab. They are also in large, hundreds, 200, 300. Again, everybody need megawatt. Then public charging, solar plus BSS. So friends, these all are various applications. We cannot ignore them. We are talking about the various aspects of moving ahead in the value chain. So, but how? As a practitioner, I am using the word practitioner because we are already operating megawatt depots, not less than 5 megawatt, 10 megawatt, 12 megawatt. Or megawatt connection I am already having. This means grid for me is not a problem, upstream infrastructure is available to me. So today the kind of a solution which we are talking from a megawatt charging solution, it means for me it is an exercise towards optimization. Today from upstream I am putting downstream infrastructure to down and then putting up my distributed charging network. I will show you next, please. Next please, So this is the way forward. Today we are at grid connected power in terms of distributed DC charging. We are, of course, megawatt scales is our next inspiration, but we have yet to see how practically it is and how it really give advantage, and then the renewable integration and the energy storage. Move next, please. So these slides is very, very important to bring to attention of everyone. What are the typical parameters which are crucial when we talk about in terms of the operation management? The CCS to standard, the interoperability is the fundamental. When we talk about bus, truck or anything, so are we ensuring in terms of interoperability at such a high commercial vehicle level? Where are we on that? Then the efficiency. So today the general achievement with me is 95%. Are we talking bigger than that? And then in terms of performance degradation year over year, then operating temperature range. India is a high temperature, 55-degree normal, in Delhi, we are sitting. You come in June, you can see the real fact on ground, how any product works. We are talking about the gun with the high current range. You see in the field, does the gun can tolerate the sand, which comes, lot of sand from the vehicle, the high temperature, the melt. So these are fundamental maintenance concerns, how we can address. And then the voltage range, current range, load, see all these factors, and then backward and forward integration, vehicle to grid, renewable integration, ESS integration. See, as per the subject, I am trying to put a thoughts. Okay, this is something where we all are, moving ahead, and we are all are looking at how we can bring that, each and every element, putting together as a system integrator, as an executor, as a charge point operator. Move next, please. So these are another aspect in terms of interoperability, EV side integration. As we've been knowing, see, ultimately it has to work with the EVs, about the batteries, the technology, the component within the EV. We are talking about connectors. So whether the vehicles are ready to adopt to that level of current, voltage and everything, and then the standards. So these many things we have to put together as a thought, then we come to a conclusion where we are moving, how we are adopting product, technology and service application on ground. Moving next, please. So this is a subject which Anand was just trying to mention in terms of, you can see in terms of, let's say city level planning. We are putting up megawatt charging for depots. There are, let's say in one city we are planning at the moment 1200 buses, close to 1200, 1180 buses, 14 depots. Each depot minimum 3 megawatt. And then we have worked out based on our modeling tools, like how many chargers for 240 if I deploy for each depot. Then how much utilization I'm getting from those chargers. And then what is the kind of each charger is a kind of an investment. How many buses I'm charging from that charger. So these numbers are something which are ground realities. And how in India, or to that matter for the world, we are setting the benchmark. What are the best solutions we can deploy at a city level? How we can collaborate with all the stakeholders, starting from the DISCOM to the charger manufacturer to the component supplier to the application provider. And then finally, how we can do the energy management, how we can optimize that. That's the fundamental rule. Not just each depot, but at a city level. Then how many people, each depot I have to operate 24/7. So these are fundamentals I'm trying to share with my global audience here. Please see, it's not just what the product we developed in R&D, but how we operate that on ground. whether it is really maintenance free, whether it is really suitable for the end customer and the user on ground, easy for them to use and adopt. Move next, please. So this is a typical layout. We all know, yes, it is there. And from a per gun wise, when we talk about interoperability standards and the multiple EV application, 60 kilowatt to 180 kilowatt. This is my current, kind of an understanding. Probably with the more evolution, we can move to the value chain, enhancement of that value chain. Move next, please. These are few driving factors in terms of when we talk about megawatt, what should be there for a depot charging, in terms of sequential charging, master slave arrangement, multiple dispensing unit, and then in terms of various standards which has to be aligned across the value chain, and then interoperability. Move next, please. And this is just the last slide to set the expectation. We all are moving towards the net zero in terms of our bigger objectives set by our Prime Minister, government. So in terms of that, today I am at 95%. Does my system will give me 97%? Today I am at 98%. Can I get 99.5%? Today I am grid connected. How can I make it renewable connected? How I am getting the real time, CMS port? Today I have to dependency on the telecom network. How I can enhance my that integration? What are the minimum TAT sports? Then industry quietness. Today there is a lot of noise. I have to accept it. This is totally not acceptable. Then how I can enhance my utilization? Today my one charger serve 5 to 6 buses. Can I enhance that also? What is the scalable solutions? And then less space requirement. So these are certain kind of expectations as a benchmarking. I wanted to see going forward. Of course, we are already in our this whole executional plan, strategy, and working it out. So looking forward to everybody's support to us, and we will be here to definitely take away whatever best thing we can have from the global market. Thank you very much, and let's charge up together. I hope I'm able to wake up you all here. Thank you.
Thank you, Manoj, for this excellent presentation. You made my day, really. I think everybody's day, and then thank you very much for this solution. So we would open for the question answer. If any question from audience, we would appreciate. Otherwise, we may go ahead.
Thank you so much. My name is Rhythm Singh. I am a researcher and assistant professor at IIT Roorkee. So we are looking at a few different problems related to EV charging. So one of my colleagues also works on developing wireless power transfer mechanisms. And another group here, we work in terms of looking at the feasibility of point charging solutions versus battery swapping solutions. So a few things, a lot of interesting things I got to hear, but I just wanted to understand, like, is there a scope for battery swapping solutions in India, or are we completely going for point charging solutions?
As I mentioned in my opening points, each technology has its own application, right? So here, when we are talking about a large commercial vehicle, buses, trucks, right? So battery in itself is in tons of weight, right? So when you have to talk about swapping, so you can imagine the size of those equipment, the replacement of those batteries, and creating those numbers within a city in itself is a big, big challenge. Right. So that appreciation is not there for high commercial vehicle. For two-wheeler, three-wheeler, for that level it's okay. Second, to answer on your that wireless charging, again, we talk about induction and then putting up the e-highways. How in terms of, putting up costing element onto the vehicle side. Please understand. Here we have to simplify each stakeholder's life, right? Infrastructure has to create for multiple stakeholders, which should be usable by multiple users. And now, EV in terms of, we have to think through how we can do its cost optimization. If we add more cost, like we were the first one as a group, as a company, in 2015, we bring our first pantograph-enabled electric bus, right? We were also given a good thought in terms of bringing best of the product and technology. But does that suitable for our market? Are we ready for that level of cost? Are we ready for that level of infrastructure development? No. So ultimately, as I'm mentioning, certain things are good to have, good to talk. But everything has its own timing, execution, and then, adaptability. So whatever we develop, definitely we as a country, we as a people, is our time. We are the benchmark. And that's what I'm telling with a lot of confidence, the way we have implemented in the last 5 years, and we have come on in scale. So my whole appreciation to our innovation, the people like you have a great potential. The only thing is you have to just connect with the ground realities. We are here to help. We are working with a lot of startups. We are here to help you out. But, think through solutions which are practical, adaptable for Indian context and the global context. We can definitely scale it up. Thank you.
Yes, please.
Hello. Thank you. In continuation to what the person ahead of me was asking about these technologies, and you talked about the timing of every technology, I want to bring in vehicle-to-grid technology into the focus. One of the panelists was talking about discoms and the bottlenecks with the connectivity at the distribution network. And when we talk to the utilities, the question is what's in there for us if huge EV load will be connected to the grid. We look at the ancillary services these loads can provide, and when we see the charging solutions of in megawatts, then that is actually a good way, a good quantum of energy which can actually serve the purpose of these ancillary services. So my question is, since you are the active players in this ecosystem, do you see this vehicle-to-grid technology happening in near future, or like you said, the timing is all wrong or too early right now? Another follow-up question to Mr. Max with the beautiful chargers. Are these chargers capable of handling these bidirectional power flow yet? So these are my two questions. Thank you.
I would take up this question. Thank you. Excellent question. Excellent question. This is very much a possibility. We are trying to do a pilot in near future. Very quickly we are trying to do a pilot. When we are looking, it's like one of the technology that two-way electrons are flowing and then you are charging your, it's not only one thing. If you are seeing it in a different angle. Recently I had a discussion with MD WBTC, West Bengal Transport Corporation. So they are inducting almost 1200 buses. If I assume that one bus would carry 100 kWh on board at least, minimum. So now you have 120 megawatt of kWh portable charging running on road. If it is carrying passengers, it is working. If it is not carrying passengers, an arbitrage can be done, and this can be exhausted to the grid at the peak hour when you purchase electricity at the cost of 12 rupees from the grid, or maybe the utility is purchasing the electricity from the grid at highest cost. So this gives you another angle to think that this is very much important. It's not the technology part. It's from the business angle also, that whether your buses are running or your buses are, lying idle, both of the time they are making money for you. So this, particularly this vehicle to grid seems very, I am very excited to go ahead and do this. And in near future, you would hear from us that yes, we have done a pilot, maybe next ISUW, you would have a case study for this.
Thank you so much. Would like to hear from the manufacturers as well. What's their take on vehicle to grid?
Yes.
Maybe Mr. Gupta can come in, or Max. Thank you.
I will reply yes about vehicle to grid. The requirement of vehicle to grid is to utilize stored energy in the vehicle during the emergency when the grid is not available. So here question is, do you have only one method? Means vehicle to grid means can we utilize only the energy stored in the vehicle for the utilization in case of non-availability of grid, or any other thing also can we do? So Answer is yes. In vehicle, we can store somewhere 50 or 100 kilowatt energy. That's it. But if we go for the large scale energy storage system or solution, here I'm using the word energy storage, not battery energy storage. So battery energy storage is a one part of the energy storage system. Energy storage system can be anything, and the storage medium can be anything. Like battery, one example. Mechanical energy, flywheels, air compressors, which can store the energy in terms of megawatt. Maybe some water storage, reservoirs, pump storage. That is also one solution. So likewise, battery is a chemical form of the energy storage. Likewise, we have the lot of things where we can store the energy and we can keep for the long time also. New technology is a hydrogen, where we use the solar panels or the renewable energy like wind, and we can convert into hydrogen, and whenever required we can utilize again the liquid hydrogen into the energy. And that is, I think, the most advanced technology which is now coming and maybe available in 2-3 years. Wind is a form of to generate the energy. We cannot store. We need to store in form of mechanical. Again, wind is again the mechanical energy transfer. From the wind to mechanical, we are converting into electrical energy. Then again, to store the energy, actually we cannot store the energy. We can convert energy somewhere. So hydrogen is again the conversion of the energy. Like electrical to mechanically, we are converting in terms of fuel cells, in terms of air compressors. Likewise, hydropower, that we can store energy in terms of water. We can store energy in terms of the temperature, things like cold to heat, heat to cold, thermal turbines. Like we can use the storage of the energy. So vehicle to grid, we are talking only about the vehicle to grid, but vehicle to grid is having lot of limitations. Actually, vehicle has to receive the instruction from the grid. That grid is having demand, and vehicle has to supply back to the grid, or maybe vehicle to home. In case of vehicle to home, vehicle will be able to supply power in your home only, not back to the grid. But if you are talking about the vehicle to grid, means that means the entire ecosystem, communication, the complete chain from the power generation station to the vehicle, everything should be smart enough to communicate with each other. That means power line communication will be required from generating station to the transmission lines, to the local distribution channels, what we call as a state level RLDC, regional load dispatch centers, or SLDCs, state load dispatch centers. So this type of stations should communicate with the vehicle, and they can send demand to the vehicle on the real time. And in India, the smart meters, smart grid, I think from past 10 years we are discussing about the smart meters, smart grid here and there. But yes, there are some setup where we have created the pilot projects running on the smart communication PLCC, but not on the actual ground. But if we go energy storage, if we go in terms of megawatt, 1 megawatt, 2 megawatt, at least, let's say 10 megawatt scale at the substation level, so that large storage system easily can communicate with the load dispatch centers, and they can work as per the demand of the load dispatch centers. So that will be much easier, and we can store large energy in the one place, maybe 10 megawatt scale of energy we can keep, and we can utilize as per our wish. Peak demand, when our peak demand generally comes from morning 9 to 11 will be the peak demand when the most of the EV will be charged. Evening time will be the peak demand. And in night, let's say from night 12 to morning 5 or 6 o'clock, there will no demand in the grid. That time we can charge those 10 megawatt storage, whether it's battery or anything. We can store the energy into 10 megawatt system, and we can utilize morning 4 hours, through hours, and evening also. In that way, we can utilize energy storage system, and we can support our grid also. Thank you.
I'd like to answer your question in 2 sentences. 1 sentence, technology is available. Yes, with our cable you can do that. It's not an issue. I mean, there was a lot of talking from the very beginning. I think in the future, and it depends what time frame you're looking for the future, it's becoming a very important part, but there are a lot of hurdles to take, all the communication. So in our area, we try that to work for your own house or for a small community, but if you want to fully utilize, I think it takes another 5 to 10 years to find ways and means to do it.
Sure, thank you so much.
Thank you very much. I think we have addressed the questions. And now I would request the chair of the session to give his closing remark, and then we'll find out.
Thank you, Anand. Thank you all my speakers and all audiences. I think it was a very, thought-provoking session. In terms of, we started with Gerald, who gave us the opinion about his EU, demand in the market, what is the scenario, what type of chargers they are going to do, what type of vehicles will be required. Then we had a presentation from Hitachi, Mr. Giridhara, who gave us the thought of, how the coordinated charging can help in reducing the load. And also what I mentioned in my opening remark, the collaborative and cooperative approach among all the stakeholders. That was, a very important point to take. Then we had Mr. Max, who showed us the practical, how he had developed the guns, and it was really everybody, saw the physical gun at that high power, basically 1000 ampere and more. And they are one of the leaders in developing this cable, especially a lot of railway cables and telecommunication, they are pioneers. And this also I could see that it's a water-cooled cable. So, in the future they are telling, shortly they are going to come out with 3000 ampere gun. So we will see the next, when he comes next, he will bring that.
We just follow, like everybody, the market requirements.
So I could see in his slide, the target date they have taken is Q1 of 24 to develop the 3000 ampere gun. So I think next session we will have that. And then Mr. Jayaprakash Singh, I think very practically he gave us the idea about what is really required, 1C, 2C, 3C, 4C, and ultimately what is the real need in the market. Developing is one thing, development has to go, it has to be there in the market, we need to be ready with the product, technology, and then later on things may follow. Everything takes time, and what Mr. Manoj Gupta rightly, point out is practical experience on how they have developed in last 5 years and made one of the largest fleet of bus operations, because we are seeing a lot of two-wheelers, three-wheelers in the market, but as far as the bus is concerned, it's a complex, operations, and I think they are taking on the GCC model, I think. So that is also even more complicated, that you have to do everything of your own. So I think he has practically given all the ideas, and future ahead, how efficiency can be more. Right now we are operating 95, 96%. What is the utilization? What is the utilization of charger? How the grid can be enhanced? And all those things are there. Upstream network, downstream network, cable sizing, all those things. I think a lot of good discussions and a lot of good takeaways. And I request all people who are today have listened to this all presentations, may kindly, work on these areas. It is just a, may not be okay, we have come to the conference and then, so you can have the mail ID or something from Mr. Anand.
Every information is available in public space, and please reach out to me in case of
Because it
any
is a need
query.
of the hour. Our country needs it. We need it. As a human, we need it. So, all of you are really, I am so happy that you have been sitting throughout after lunch session, questioning, listening very patiently. So, such a, beautiful and good audience. I thank you all. And thank you all my speakers and especially Anand.
Thank you, sir.
And all ISDF. So, I once again request, kindly continuously evolve your mindset, from IIT, what is your name? Rhythm Singh. Yeah, so like all the researchers are here, so academia, technologists, industries, service providers, all have to collaborate and then work together. Then this dream can be realized. So thank you very much, and let us hope for getting the CO2 reduction and do good for the earth. Thank you. Thank you all.
Thank you, everyone. Thank you, speakers joining us online, Gerhard and Giridhar. Thank you very much for being with us. And now I would request the chair of this session to facilitate our speakers with the mementos. So if you can have a quick photograph, the group photograph, and then. Thank you. So I would request now Mr. Max to kindly get the mementos from our chair. And now I would request Mr. Jayaprakash to please kindly come and then collect your mementos. Now I would request Mr. Manoj to kindly come.